Okay, looking at this Japy milk tank. Customer's milking last night and it's knocked the trip out, so we've got a good earth on there. We'll confirm that. We'll put that against there. Yep, so that's a good earth. And I've already tested this, but we're just to prove it. That we've got 4 contactors. I think this one's a heater because it's just linking. Just links the lives across. I think that runs. It's got an inline heater for the wash. I think that is one of the compressors. I think that's the other one, and this one might be the wash pump. Let's see. 0.14. That's on the neutral, and then we'll test the live. You'd expect them to be the same, but if the motor is completely burnt out and the live and neutral aren't connected, one might be okay and the other one might be shorted, so it's always worth testing everything. I mean, I've had that with heaters where one end of the heater is open circuit and the other one's shorted 7 mega ohms, which is not great, but it would run 7 again. Let's try on there. That might be earthy because we're on the heater now. It might go up the neutrals. 13, that's a bit better. And let's try this one here. 44. Conventionally here, your power comes in on the top of a contactor and your switch things are on the bottom. Every now and again you'll get one that's wired the other way. That should be the incoming neutral. Sure, I'd expect would be fine, yeah. So whichever one that one goes to, by the look of things. So we need to be at the other end of the tank. Okay. Got 2 compressors. Got a Bristol Scroll, which I think have been bought by Danfoss now. They used to be badged up as York. That's probably why you can't get them anymore, because I think Bristol's gone bust or something. And the Copeland one, I think this one's been changed in the past, long before I started working on it. It's got a check valve here. These ones don't have a check valve in the head. These do, so that wouldn't be needed. So I think that is there when there was a previous, probably a Bristol compressor on there. And these are actually different sizes. I think one's, I don't know. One's say 3 horsepower, and one's like 3.5 or 4. They're mismatched for some reason, just to get the duty right, I assume. Anyway, got that test lead there. Let's pick an earth. Let's go in the actual earth terminal. Test button. Got a good earth, right? Let's try the neutral. That is earthy, which is the Copeland one. Let's try that one. That's the live. That is earthy, and then let's go over here. And that was about 7, I think, or something. 7, 9. Yeah. So the Bristol one is okay. I think that's a smaller compressor, which is a shame, because it'd be better coping wise if the bigger one was okay. So right. We could pop the wires off of here, I think it's probably best. I doubt it's the cable because it's so short, but you could have a short in the cable. So if we take the terminals off of here, we can test the compressor and then we can test these again. Fan motors are probably wired into this outside the condenser fan motor. It's got remote condensers on this, so the pipework goes off and round and up to outside for the fan motor, so it could actually just be the fan motor that's faulty because they run off of the same live and neutral. Yeah, let's have a look in here, I think. Okay, well that looks okay. I have had them where the wires have sort of rubbed through and shorted out, and it's been external to the compressor. Right, so we will draw a little picture of where the wires go so we can put them back on again, should we need to. Okay, these two, blue and the black, pulled off, is slid off nicely. and the brown one was actually stuck. So we've pried that off and it's got a little bit of a mark there. I think it's either had a loose connection or it's suddenly pulled so much current it's actually welded the brass or copper, whatever that's made out of, to that terminal, and that's why it's broken as I've pulled it off. So it isn't looking good for that compressor. It's had a lot of current go through it. I think the start current on these, the lock rotor amp is from, if it's good, is 100 amps. So if it's shorted out. Okay, it's on there. 100 mega ohms, that one's off the scale. .300 mega ohms. 200 mega ohms. Right, let's confirm our ground is still good because we're over there. The ground is still good. Okay, so let's go back on these wires. We're on the blue one. It's showing a short. Yeah, I've got that stuck in there. There we go. Brown one's going to probably show a short as well. 0.2. And the black one, which is probably off the capacitor. That'll be okay. 0.6. Got to be careful that you can, if you're measuring them, you can actually charge them up and get a zap off them. So I think the next thing is going to be. I've got a feeling these might have had a fan speed control. Be it might have been a fan cycling switch, because we've got a HP over there by the expansion valve, and then we've got another one in the discharge line. And then we've got an LP switch here. So we've got two. Why would you have two HP switches? Well, one of them is probably a fan cycling switch for head pressure control. So I'm not sure. We'll have to have a look at the. Sometimes there's a diagram on the lid, but it's not with this. I'm not sure whether they fire. They might have one fan come on with the compressor and the other one come on with the HP switch. It might have all been disconnected because the tank's probably 20 plus years old, 25-year-old. So it's had some bodging done over the years. I think those are the wires there. They probably, that goes, isn't there one that goes into here? And then there might be a multi-core wire that goes off to the condensers. It's probably one of these two. It's got heat recovery on there as well, so one of them probably goes to the pump for the heat recovery. Anyway, we'll have to trace some wires, but this might be okay, which would be good. Okay, right, so we've got, that's our fan supply wires coming in from this unit into this, the one for that box for that unit, and they go onto this wire here, which goes off to the heat recovery water circulation pump, and also up here to that wire, which is the braided wire, which goes out to the condensers, and then the other two wires from that come off the live and neutral for this one. So that's our fan supply wires. So if we split this here, we can see whether it's the circulation pump that's failed or the fan. Okay, split those up. I've just twisted the live and the neutral together, and we can test them at the same time. Yeah, the fan's checking out okay. Shorted out. So that, I think, is the circulation pump for the heat recovery. So we can put all this back together and leave that disconnected. Okay, that's our little pump. It's like a central heating pump. Hot gas goes through this plate heat exchanger, so you've got gas, refrigerant going through one side, water through the other, and that little pump circulates it through this tank to get a store of hot water. Let's get a cover on. Right, it smells a bit burnt in there. I think it's got some sort of lever thing to get the cable in. I think you just move that little toggle and the wire comes loose. I need 2 hands for that. Okay, that's the neutral. Incoming neutral from the tank should be about 7. Oh, it's 4. 4 megaohms is fine. That's the incoming live. 4.6. I'm not sure if we're going to be able to get into this. Might do this, try that. 0.16. Yeah, so that's shorted out. Pump shorted out. We'll make them safe and then we'll turn the tank on, see what happens. Okay. 10.3. That's milk's going to be probably not any good. It's been sat that long.